The CSD is the Cambridge Structural Database. It's the product, or the principal product these days, of the Cambridge Crystallographic Data Centre. And it is a fully retrospective database of small molecule crystal structures, where small molecule means anything up to about 1,000 atoms, including hydrogens. And it sits between, if you like, the inorganic databases on one side and the protein data bank on the other, which take all the large molecules and polypeptides, proteins, polysaccharides and so on. They will all be in the PDB, but we have the small molecules, which essentially are organic structures and metal organic structures. Today, it's well past 500,000. We passed 500,000 in 2009. I think it's nearly 600,000 now. But if you think that in 1965, when this all started, there were only about 5,000 crystal structures known at all. So the development of the subject and the productivity through various scientific and technical developments that have gone on has been so dramatic that it's sort of moved from being a technique of last resort to being the technique of choice in most modern chemistry departments. It is the analytical tool that organometallic chemists and organic chemists rely on. So the size has increased dramatically, and it's increasing by 40,000 a year. And that number itself will increase. So CSD really is a huge reservoir of information. And as I said, even as a PhD student, I realised that if you could collect all this together, you had a research tool which was of considerable value. So the first topics I started working on were conformational analysis, and almost following on from some of the work that Hoffman had done actually was what did the crystal structure data have to say about the structures of small ring compounds, small highly strained ring compounds, and the conformations that substituents on those rings would adopt. And this was an interest that carried on all right through into the 90s, where we were trying to devise ways to do conformation analysis of a particular ring system or acyclic system as automatically as we could using the CSD. So we were developing techniques like cluster analysis and principal components analysis and so on, for taking huge bodies of data and as rapidly as possible getting the results that were relevant to us. And of course, as I said earlier, drug discovery people had taken a liking to the database, and this was just the sort of thing that they were interested in. So there was a lot of work went on conformations. In the middle of the 80s, there was pressure on us from outside, actually, to produce updated tables of mean bond lengths. I regard that as it was called the winter of our discontent. So we had to sit and go through the database and get mean values, and it became a very, very repetitive operation, but the paper that resulted from it has become, I think, a citation classic. It's been cited, many thousands of times by scientists who want a benchmark value for a CO bond in a certain chemical environment. So that went on, and we then collaborated with Guy Orpen and his team at Bristol to do the similar thing for metal organic structures. So that occupied quite a lot of time in the mid-80s. A lot of work went into that. And then I think from there onwards, the interests of structural chemists and also industrial modelers switched to, for example, how does a drug interact with the protein active site? How do crystal structures form and hold together and so on? And so therefore there was a switch towards studying intermolecular interactions, whether they be hydrogen bonds or electrostatic interactions. And really that's carried on to the present day, where that is still a very, very important use of the CSD. It's probably it's the biggest body of experimental evidence on intermolecular interactions that is available. And if you look at the papers written by others using the CSD, this is easily the most popular topic, and we've made our own contributions, not only in terms of the crystallography, but also in terms of the strengths of these interactions, using any available high-level ab initio methods that we've been able to import into our research program. So that's been really the thrust of it, but it's always been linked up with, in a sense, what do our customers want to know, and can we exemplify the sort of information that these people need through our published papers? And I'd sort of say that published papers, I shouldn't probably say this, are actually our best promotional tool. You can have as many flyers as you like, but half a dozen really good, high-quality papers in a top journal are extremely valuable way of promoting the CCDC, the CSD, and everything that we do. The CSD has obviously been critical to the work that we've done here, but I think I'd almost reverse the statement and say the work we've done here has been critical for the CSD. Let me give you an example. So in the late 70s, we used to go out and obviously go to academic conferences, and we'd describe the CSD and so on. And the first question that used to come from people in those early days was, okay then, so what use is it? And it became pretty clear towards the end of the 70s that we needed case examples, case studies. And in a sense, the research program responded to those sorts of questions. Okay, we can quote other people's research, but that was also at a very early stage. So we felt that we definitely had to do some research of our own. And throughout the 80s, there was this underlying effort to produce research papers that we could then talk about at conferences and at workshops that we ran to promote the CSD in those days. So I think it's been a very synergistic thing. The research and the database have developed essentially together. The initial research obviously was connected with the CSD itself very directly as a promotional, if you like, this synergistic development of research and the database. Over time, research moved more towards the needs of our customers and the interests of our customers, so it became very much more life science flavoured, if you like. And that's certainly true as we developed other products from the CSD, derivative products, to diversify our product base. Then there was research which was required to understand those new areas that we were moving into. And that's really been the developmental cycle in the research area.